Welcome everybody. For this video I'll be discussing and going over the reactions of epoxides. So let's get started with this, okay? So this will conclude all the material you guys need to know in regards to ethers. So the next functional group I'll be moving on to is aldehydes and ketones. So let's get started, okay? So there's two categories that we're going to focus on with the reaction of epoxides. The first condition is basic conditions, and the second condition is acidic conditions. Okay, so let's start off with basic conditions, and under basic conditions you need a negatively, okay, so that's a negative and a circle around it, negatively charged nucleophiles. Okay, so what are some examples of negatively charged nucleophiles? Well, OH minus, Grignard reagents, right? So basically carbons with negative charges on it, or sources that produce, right, H minus. Okay, so those are some examples of negatively charged nucleophiles, right? So let's get started with the reaction of a Grignard reagent with an epoxide. So we'll be focusing on this epoxide here, and we'll react that with a Grignard reagent. So we'll keep it simple. We'll just have like a 2-carbon chain like this, MgBr, and then we have H2O, H plus workup. Okay, so we're supposed to determine the products of this reaction. Okay, the product of this reaction. What will happen in this reaction, the product of this specific reaction will be this. I'll show you the product and then I'll go over the reaction mechanism. Okay, so you'll have something like this. You'll have OH there, and then you have 1, 2. So that'll be your product of this reaction. Okay, looks kind of strange. It doesn't really resemble the reactant, but I'll go over the reaction mechanism with you guys right quick. What happens is under basic conditions, okay, so I'm going to say this twice for you guys because this is a very important point. Under basic conditions, the nucleophile, which is this 1,2 carbon chain, or any type of nucleophile under basic conditions, will attach to the less substituted carbon, okay, of the epoxide. So there are 2 carbons that this nucleophile can attach to. You can either attach to this carbon here or this carbon here. Well, this is less substituted than this carbon. You have 1 carbon here and 1 carbon here in regards to this atom, and in this carbon you only have 1 other carbon attached to it. So this is more substituted here. So now the nucleophile, which is again the 1,2 carbon chain, will attach over here. So this is how the reaction mechanism will work. Again, you have MgBr. What happens is that it will attack the less substituted carbon, right, while kicking off a pair of electrons here to the oxygen. Okay, so that's the first step. What you get is a 1, 2, 3, 4, 5 carbon chain with a negative charge. Remember, I told you guys that this is considered an alkoxide, right? So now what happens is that your H plus H2O workup neutralize that negative charge. H plus, sorry about that, so H2O, H plus work up, neutralize that negative charge, and you're left off with your alcohol. Again, I'll just write it right here. Nucleophile. So this is under basic conditions, okay? So make sure you guys got that clear. This is under basic conditions. Nucleophile attaches to less substituted, okay? Less substituted carbon, okay? And this is a very important, okay? Very important. 5 exclamation marks for you guys, okay? Very important. Attaches, okay? So there you have it. That's basically the reaction of epoxides under basic conditions. So again, if you have a if you had an hydroxyl group or something like that, it'll follow the same reaction mechanism. And again, nucleophile attaches to less substituted carbon. So now let's go over acidic conditions. Okay? Under acidic conditions, we will find that the opposite of this is true. Okay, that the nucleophile attaches to the more substituted carbon. Okay, so that's under acidic conditions. So let's get started with that. Okay, acidic conditions. So again, what do you need for acidic conditions? You need H plus and a neutral nucleophile. Okay, so that's the conditions this reaction will work under. Okay, so again, we'll be consistent and we'll focus on the same epoxide that we dealt with in the first example. So sorry about the blurriness, it should go away pretty soon. So here's our epoxide, and we will react it with, before I move on to what we will be reacting it with, I'll give you an example of what a neutral nucleophile could be. And you guys could come up with your own examples of neutral nucleophiles. I'll give you guys one. That's a neutral nucleophile. There's lone pairs on it. It could react with an electrophile because it could donate a pair of electrons, it could donate a lone pair to an electrophile. So that's an example of a neutral nucleophile. So let's actually use this specific neutral nucleophile as the reagent we are going to react with this epoxide. Okay, so again, we'll be using H plus and this alcohol. Okay, so it could be any type of alcohol. I just picked the secondary alcohol in this specific example, so any type of alcohol will work as long as it's neutral. So the product of this reaction will be a little bit more intimidating in the way the structure is. So it'll look something like that, I believe. That's how it looks like. Yeah, exactly. I think that's what it is. So we'll go over the reaction mechanism just to verify that this is the structure, because that's the best way for me to determine products, is going over the reaction mechanism, because sometimes it's a little bit difficult to exactly draw the structure without going through the mechanism. So let's go over it right quick. So the reaction mechanism is pretty straightforward. First step is to okay, there's your H plus. First step is to protonate the oxygen, right? You have a lone pair on it. You actually have two lone pairs, right? You're going to use one of the lone pairs to protonate the oxygen. Okay, that's the first step. Now you form a protonated oxygen. It has a positive charge. It could serve as a very good leaving group. Now you could kind of break this this epoxide. So the next step is where your nucleophile attacks. And if you guys have noticed from the basic condition and what you guys will be seeing from this acidic condition, this next step follows an SN2 style, okay, of reaction mechanism. So again, the alcohol we're focusing on is this alcohol over here. It has lone pairs, and again, in acidic conditions, the nucleophile attaches and attacks the more substituted carbon. It won't attack here, but rather attack there. So here you have lone pairs attack here, right? You kick off this bond onto the oxygen to make it neutral. So the product you form is, you get some more space. So the product you form from this is, again, you have your alcohol, and now you have that as your intermediate. Okay, you still haven't lost the H, so now this oxygen has 3 bonds to it. It has a positive charge on the oxygen. So the last step in this reaction mechanism is kicking off this pair of electrons, so you're losing this H. Okay, so again, this H is catalytic. It reappears at the end of the reaction. So you kick off the pair of electrons onto this oxygen while losing this H, and the product you form is right there. Okay, so actually, let me make this a little bit more visible. Let me make this a little larger for you guys so you guys can see. So again, that's the product of this step right here, and the final product is that once you do this step right here, kick out this pair of electrons onto the oxygen. And again, this is the mechanism for under acidic conditions. So again, the key thing you guys need to take away from this specific category is that the nucleophile attaches to more substituted carbon. Again, I give you guys 5 exclamation marks. Very important. And this is again under acidic conditions. Very key, very important. So again, I use this specific alcohol as a neutral nucleophile. In any case, you could come up with your own neutral nucleophile as long as it follows this specific format. Okay, so I said neutral nucleophile, so basically your nucleophile has to have a bond, has to be bonded to an H like that. Okay, your nucleophile needs to have an H attached to it. So there you have it. That's all it is to the reactions of epoxides. Pretty easy. You just need to know under what condition is the reaction occurring, and once you determine that, where the nucleophile is going to attach. Is it going to attach to the more substituted or less substituted carbon? And again, you determine that based on what type of condition you're reacting your epoxide with. Okay, so that's all it is, and this concludes the topic of ethers. And I hope you guys enjoyed. So we'll be moving on now to a new set of functional groups, and that is aldehydes and ketones, like I said in the beginning of the video. So thank you for listening. This is Moballer12, and I'm signing out.